All right, so the last thing we're going to talk about is the application, which is really the income distribution. So the U.S. Census Bureau compiles and analyzes a great deal of data having to do with the distribution of income among families in the U.S. In 2014, the Bureau reported that the lowest 20% of families received 3% of all family income, and the top 20% received 51%. So if we look at this, under 21,000, that's the, 20% of people, and 3% of the families did that. Okay. So, 20 lowest 20% of families received, 3% of all that. Then if we moved up and it says the top 20%, so everything above this. And so this is kind of cumulative. It just keeps adding and adding and adding because, we're just moving up and moving up. And so it's taking the area to the left. And so when we get to this, or to the point eight, it's everything to the right. And so that means the top 20% is going to be 51%, and that's why it's 51%. So these two figures kind of give you a distribution on how it looks. Now the graph of y equals f of x in this figure down here, okay, y equals f of x, is called a Lorentz curve, and it's usually found by using regression analysis, which is what we've been doing to do a lot of our stuff. Now, the variable x represents a cumulative percentage of families at or below a given income level, and y represents the cumulative percent of total families' income received. So, for example, if you have data point zero point 0.4, comma, 0.11, that means the bottom 40%, so again, we're going to convert that to percent, the bottom 40% receives 11% of the total income for all families in 2014. Whereas the data point this says the bottom 60% received 26% of the total income for the year. Okay. So the absolute equality of income would occur if the area between the Lorentz curve and y equals x were equal to 0. What does that mean? Basically, if this area were pushed up here and we had one curve on top of another, then we're going to have that area is absolute equality. So everything's going to be equal. Now, in this case, the Lorentz curve again is going to be y equals x, and all families would receive equal shares of the total income. 5% of the families would receive 5% of income, 20% would receive 20% of income, 65% would receive 65% of the income, and so on. Now, the maximum possible area between a Lorentz curve and y equals that is, it's not 12, it's supposed to be a half. I must have typed something wrong there. So let me see if I can get that to come back here. So we're going to say that's actually 1/2, not 12. Must have typoed that one. Now the area of the triangle below, and that's the area of the triangle below y equals x. So basically, we have this whole thing, and area of the triangle is 1/2 base times height. So if this is base times the height times the half, 1 times 1 times a half, that's equal to a half. That's why I know that's wrong. All right, so all the income would be in the hands of one family and the rest would have none. So in actuality, though, the Lorentz curve lies between those extremes, between 0 and 1. So absolute equality and absolute inequality. Those are where it actually lies. And we use a number called the Gini index to measure the income concentration. So this is a ratio of two areas, the area between y equals x and the Lorentz curve, and the area between y equals x and the x-axis. And we're going from x equals 0 to x equals 1. And our first area equals this, 0 to 1 of x minus f of x dx. And the second triangular area equals half given the following definition. All right, Gini index. So this is what we're doing. Y equals f of x is the equation of the Lorentz curve. Then a Gini index is 2 times the integral from 0 to 1 of x minus our f of x dx. And again, we have to have numbers between 0 and 1. So if you come out and you get a number that's not between 0 and 1, you know you've done something wrong as far as your calculation goes, and then you should probably check something. And again, the 0 indicates absolute equality. All people share equally in the income, and a Gini index of 1 indicates absolute inequality, where one person has all the income and the rest have none. Now, this is just kind of stating it a little differently. So closer to the index to 0, the closer the income is being equally distributed, and the closer the index is to 1, the closer it's being concentrated in a few hands. So this really helps us compare income distributions at various points in time between different groups of people, and before and after taxes are paid, between different countries, and so on. So it helps us a lot in different areas. So what we're going to do on this example is we're going to repeat example 8 from the projected Lorentz curve in the year 2030, and it's given by g of x equals x to the 3.8. And so what we had initially was 2017, we had f of x is 2.6, and now we're going to say or g of x is x to the 3.8. So what we need to do is we need to find out how they differ. And so this one is already done. We don't have to do it, but I'm going to do it again just to kind of do it. And remember, we're going to go from 0 to 1 of x minus x to the 2.6 dx. Well, that's just going to be 2 times x squared over 2 minus x to the, remember, take that number plus 1, 3.6 over, divide by that number, and we're going from 0 to 1. All right, so that's going to be 2 times what? Well, if we plug in 1 there, we're going to have 1 half minus 1 to the 3.6 over 3.6. And if we plug in 0, those are 0. So that's going to be our solution. So if we plug that into our calculator, we'll have 2 times 1 divided by 2 minus 1 to the 3.6 divided by 3.6 parenthesis, and that gives us 0.444. So that's kind of our distribution in 2017. Now we're going to do the distribution in 2030, and this is our new g of x. So we're going to go from 0 to 1 of x minus x to the 3.8 dx. No differences here. It's going to be x squared over 2 minus x to the now 4.8. Now it's divided by 4.8, and we're going from 0 to 1. And so we'll have 2 times 1 half minus 1 to the 4.8 and divided by 4.8. 0 plugs in and gives us 0. And so now if we do that, we're going to plug in our 4.8 instead. We will get, that says 0.583. And so that is our new index in 2030. And what does that mean? Well, here, it's closer to zero, which means equality. And here it's closer to one, which is inequality. Okay. So basically, we're less equally distributed at this point in time compared to 2017. Okay. And so that's what it looks like. So, we're comparing one number to another number in time, and we're seeing if our equality is going up or down. And in this case, it's going down. So we're less equally distributed in 2030 since we're getting closer to one compared to the 0.44. So we're over half of it. And so that means it's less equality. All right. So that's all I have for this section. So hopefully that helps.